velocity at t2 is equal to alpha t evaluated from t equals 0 to t1 plus beta t evaluated from t equals t1. That's not very clear. T equals t1 to t equals t2. All right. So substituting in those values, and while we're at it, let's go ahead and substitute on the left. We know that the velocity at time t2 should be equal to 0. So we have 0 equals alpha. Here we'll have t1 squared minus 0 squared, which I will not bother to write down. Then we'll have beta, excuse me, that was, I don't need that squared on there, getting ahead of myself. Beta times beta times t2 minus beta times t1. And again, that ended up at the wrong location. All right. Notice that this equation we have here relates t1 to t2. And so let's solve for t1, since we'll need to replace t1, since it's an unknown, in terms of t2, which is what we're trying to solve for. t1 is an unknown that is not included in the given information, so we want to be able to eliminate it from our equations later on. So if I move the two t1 terms to the left, I'll have beta t1 minus alpha t1 equals beta t2. And then grouping those together, beta minus alpha t1 equals beta t2. And I find that t1 can be expressed in terms of t2 by using this fraction, beta over beta minus alpha. Now let's look at the time involved here. So for the position graph, and remember, we're interested in the amount of time required to go from this end to this end, from t to t2. So we're looking to solve for t2. So the other piece of information we haven't used yet is the distance, s. Okay. So let's look at our equation for finding the position, and that, of course, is an integration so that our x at time 2 is equal to the integral from 0 to t1 of the velocity curve, which, as I wrote above, is alpha t dt, and then we need to integrate from t1 to t2, and as I wrote above, t1 to t2, you see the equation up above for that, which is alpha t1 plus beta t minus t1. And we're going to evaluate, we need to include the dt to integrate here. Okay. So now we'll carry out this integration, and recognizing on the left that the value that we should get is S, the distance between the two train stations. We'll go ahead and fill that in. Here we'll have 1/2 alpha t squared evaluated from t equals 0 to t1. For the next one, let's break this into a couple parts here. Let's see. We'll do it. We'll break this into 3 integrals. Okay, so we'll have 1/2. Let's see. Excuse me. We'll have alpha t1 times t evaluated from t equals t1 to t2. We'll have 1/2 of beta t squared evaluated from t equals t1 to t2. And the third term, we'll have negative beta t1 t evaluated from t equals t1 to t2. So now we have S is equal to, here we have 1/2 alpha t1 squared, and of course subtracting 0 from that will not contribute anything, so we won't write that down. The next one will give us alpha t1 t2 minus alpha t1 squared. The next part here will give us 1/2 beta t2 squared minus 1/2 beta t1 squared. And the final terms will be minus beta t1 t2 and plus beta t1 squared. All right. At this point, let's look for like terms to combine. You'll notice this term contains t1 squared, alpha t1 squared. This term also contains alpha t1 squared. And the two terms here and here contain beta t1 squared. So let's combine those first off. S equals, this being a -1, we'll get -1/2 alpha t1 squared. Let me make that negative more clear. There. And then we'll still have the alpha t1 t2. We'll have the 1/2 beta t2 squared, and we'll have the, let's see, for this I want to take the preferred order. I'll put in the minus beta t1 t2, and then I'll put in the plus 1/2 beta t1 squared when I combine those two like terms. Okay, now more algebra. Okay, notice I'm going to regroup these. Well, let's just go ahead and do the substitution. Let me return back up the page here to our results we had before, which is this equation. And I'm going to put that down below here. let's see. And let's see, I'll erase the part I don't need. Okay. We're going to make this substitution into the equation above to eliminate every T1 that we find up there. Okay. So let's do that. And let me first of all note these T1s so I don't overlook any. These are all going to be replaced by the quantity to the right of the T1 down here. Beta over beta minus alpha T2. So here we'll have minus 1/2 alpha, and the quantity squared would be beta over beta minus alpha T2.